Camera's rolling. All right. So right now for this video, I'm just going to go over some of the trig equations that were in last night's homework. So for starting with number 31, we have 2 sine squared equals 1. This person decided to just get it equal to a half and then take the square root. So you have sine squared equals plus or minus the square root of a half, which is the same thing as 1 over root 2. And when you have sine equals positive 1 over root 2, sine equals negative 1 over root 2, each of those have 2 solutions, right? But they all have the same reference angle. So I'm hoping that you remember that 1 over root 2 or root 2 over 2 has a reference angle of pi fourths, right? The nice thing about, you okay?
Carrot.
I'm sorry.
Sorry.
Okay. The nice thing about having it plus or minus is you don't even have to think about which ones to pick because you've got to take one from every single quadrant. You need both the positives and both the negatives. So 1 pi fourths, 3 pi fourths, 5 pi fourths, 7 pi fourths. This is lovely. Alright, so that was a simple one. Alright, now we're going to move on to 35, which is over here. Let me zoom in a little bit. Okay. So let's see what we've got. Ooh, good job. Secant cosecant equals 2 cosecant. Don't be tempted to divide both sides by cosecant. If you see something on both sides of the equal sign, it's really tempting to just divide it or slash it out. Don't do that because you lose solutions, right? We never divide out a variable. We move everything to one side and factor. So this person factored out a cosecant. They were left with secant theta minus 2. So you get cosecant equals 0 or secant equals 2. Now cosecant equals 0 when sine is undefined. Is sine ever undefined? No, and if you think of the graph, right, then you'll know sine is always continuous. Sine and cosine are always continuous. They're never undefined. So this has no solution. Okay. Secant equals 2 when cosine equals a half. Very nice job of taking a reciprocal. All right, so now we need to know when cosine is a half. Cosine is a half at pi thirds, right? So this is positive a half. Remember, there's 2 answers to every equation unless it's where sine or cosine equal 1 or negative 1. So this one's going to have 2 solutions. So we have a pi thirds. We need another pi thirds. That's positive. Remember, cosine is positive in the first and fourth quadrants. So we need, this is 6 pi thirds. So we go back 1 and we get 5 pi thirds. So remember, all of your solutions, this is another really good one. All of your solutions are going to be either from an axis or from a special right triangle. So if you aren't sure where cosine is a half, draw your special right triangles and look and see which adjacent over hypotenuse is 1 over 2. And then you will see it's 60, and then you'll remember, oh, 60 is pi thirds in radians, and then you'll be good. 36. There's 36. Okay.
Does anybody like peppers?
Okay. There's a couple ways to think about where sine equals cosine. Right? One way, this person just said, oh, well, at a 45-degree angle, they would both be the same because, of course, cosine's a complement of sine, so at 45, they're the same. So that works, and then you just have to figure out the 2 quadrants, which would be where they're both positive and both negative. Another way to approach this problem is to divide both sides by cosine, so that you end up with tan x equals 1. And then I know that tangent is 1 at pi fourths, and then tangent is positive in the first and third quadrants. So I get pi fourths and 5 pi fourths. Either way, this was fine. So we're 3 for 3. Good job. 37. Okay, 37's got some issues, so we're going to kind of revise 37 a little bit.
That's right.
It's okay.
Why are you looking at me now? I did 38. Oh. Who did 37? Me.
Don't you have to point it out?
It's alright, Gavin.
It's okay.
I just wanted to know
Alright,
vector.
okay, so I'm gonna erase this for a moment. Alright, so we have a quadratic, and when we have a quadratic, no matter what type of a quadratic it is, whether it's a regular x squared or whether it's a cosine squared, we always start solving quadratics by first setting them equal to 0, right? So the first thing we're gonna do is set this equal to 0. Then normally the next thing we would do would be to factor, right? This one's not going to factor though. You've got cosines and you've got sines all mixed up, right? When you need to change the functions, that's when you're going to have to use an identity. There will be one problem on your quiz tomorrow where it will be an equation and you will have to use an identity in order to solve it. When you need to use an identity, the function you want to change is the one that's being squared. Because almost all of our identities deal with squared trig functions, right? So we want to change cosine squared so that it's something with sines instead. Does anyone know what cosine squared equals? 1 minus sine squared. So we just rewrite cosine squared as 1 minus sine squared. And then, look at that, the 1 minus 1 cancels, so we're left with negative sine squared plus sine. I personally don't like negative leading coefficients, so I'm going to multiply both sides by negative 1 and get that instead. How do I solve this? What do I do?
Factor.
Factor! Sine theta times sine theta minus 1 equals 0. So I end up with sine theta equals 0 or sine theta equals 1. This has two solutions. This only has one solution, right? The only ones that have one solution are where sine or cosine equal 1 or negative 1. Everything else has two solutions. From 0 to 2 pi, not including the 2 pi, sine is 0 where your y is 0. The y is 0 at 0 and pi. Sine is your y. Psi y, right? So sine is 0, your y is 0. So this, our theta for this would be 0 and pi. Sine is 1 where y is 1.
At pi over 2.
That would be at pi halves.
So I did get the right answer.
Did you get all three of these?
Yeah, I used the unit circle instead of doing that. Because sine theta equals 1 at 90 degrees and cosine squared theta equals 1 at 0.
You did a kind of a guess and check thing.
Yeah.
Don't do that. Okay. All right. 38. Let's zoom in a little bit. It's written kind of small. I use a trick for solving 38. So, do you mind if I erase this line?
Go for it.
What this says here is 0 equals 2. And
Yeah, that's like what I did on the
Okay. All right. So the equation given is cosine of theta over 2 minus cosine theta equals 1. If you don't want to mess with half-angle identities, it's actually a lot easier to redefine your variable and say, hey, let's let x equal theta over 2. Then what happens is we get cosine x minus cosine 2x equals 1. Now, we just need the double angle identity for cosine, which we should all know, right? There's 3 of them, but this is a cosine problem, so I'm going to pick the one that uses cosines.
2 cosine squared x minus 1.
Beautiful. So I have cosine x minus quantity 2 cosine squared x minus 1 equals 1. Now I just kind of distribute it out. So I have negative 2 cosine squared x plus cosine x plus 1 equals 1. I can subtract a 1 from both sides. I'm going to also divide by negative 1. I get 2 cosine squared minus cosine equals 0. Now I factor, right? So I have cosine x times 2 cosine minus 1, and I end up with cosine equals 0 or cosine equals a half. All right, coming up here, because I'm running out of space. Cosine is your x value, coho, right? Psi y coho. So cosine is your x value. So cosine equals 0 wherever x equals 0. Where is your x value equal to 0?
Pi over 2.
Pi halves and 3 pi halves, right? All right, cosine equals a half. I don't even know which family of angles, the reference angle where cosine is a half.
Pi over 6. Pi over 3.
Pi thirds, pi thirds. Sine is a half at pi over 6, right? Sine of 30 is a half. So sine is a half at pi 6. Cosine is a half at pi thirds. So cosine is a half at pi thirds and some other pi thirds, right? We want a positive a half. Which quadrant?
5 pi thirds.
Fourth quadrant, right, so it would be 5 pi thirds. All right, except that's x. What do we need to solve for? Theta. So x is the same thing as theta over 2. Remember when I first started the problem, I said let x equal theta over 2? Oh. That was how I rewrote the problem in the first place. Okay. So if theta over 2 equals all of these, then to solve for theta, I just double everything. So theta would be pi, 3 pi, 2 pi thirds, and 10 pi thirds.
So
Except
only the 2 pi.
it's got to be between 0 and 2 pi. So that one's out, and that one's out. And there's our answers.
If you were to, at the beginning, if you were to factor out the cosine theta, then
How could you do that?
like could you factor out a cosine theta and then say 1/2 minus 1?
Okay, guys, cosine of theta over 2 does not equal cosine theta times a half. Right?
Like, wouldn't the argument be like theta times 1/2? And then you factor out cosine theta.
Okay, wait. The cosine of theta over 2 is not the same thing as cosine of theta times a half. It's that, but it's not like 1/2, it's not
Okay,
that,
okay.
right? It's very, very different. What you're saying is, because what you just said is that the cosine of 30 equals half of the cosine of 60. No, that's really so. And that actually brings me to something that I was going to say later on, but you know what? Anytime, it's always a good time to write this down. So let's go ahead and put this in our notes right now.
You want to change the
We have
video?
one always and 2 nevers to write down in our notes, and one of them is the one that was just brought up. Here we go. So, 1. Never, ever change the argument. Do you know what I mean by argument? Okay. Of a trig function without using an identity. This is so important that if you ever do it, I'm going to take full credit off.
We're not exchanging it for a variable.
No, if you redefine, that's different. But if you're just going to like say, hey, let's, the most common one you'll see in limits today is to say that sine 5x equals 5 sine x, right? You can't do that. This is not true, right? You should be squinting because it's not true, right? Okay. So no, you cannot change the argument, the input of a trig function unless you are using an identity. This is so important that if you do it on your quiz, I'm going to put this on the video. If you do this on your quiz, not only do you use full credit, you get the stamp.
Oh, dude.
Yes.
What does the stamp say for us that are not?
Would you like to read the stamp? Read it to everybody.
NCTAOATFWUIAI. Never change the argument of a trig function without using an identity.
Okay.
I actually brought a stamp that says
One of my students gave it to me because I got so tired of writing that out in words that I wrote an acronym for it, NCTAOATFWUAI, and I was writing that over and over and over, and I got so tired of writing it on so many quizzes that one of my students for Christmas gave me a stamp. Right? Yeah.
Classic.
Yep. Okay, so that's number 1.
Now I remember for it not to use
Okay.
it.
Number 2.
Do you have a stamp for number 2 too?
No, I don't have any other stamps. Never divide out a variable.
We should get you some more stamps.
Have a stamp for that.
Okay? We never divide out a variable. If you see a cosine on both sides, you don't get to divide out the cosine. You have to move it over and factor, right?
We should get you a stamp for that.
Okay? And number 3 is an always. Always set quadratics equal to 0 before factoring. This one, if you do this on your quiz, what are you going to get?
Minus 20.
Minus 20. That's in addition to any other points you missed for that problem or any other problem. Now the entire quiz is worth 32 points.
So you could you get a negative score?
I am very kind in that I cut the score off at a 0.
Oh, so
Okay.
kind, so kind.
Now,
thank you.
I could give a negative score. I could make you lose points from your total points for the quiz, but I'm not going to. But I will let you earn 15 of those points back. So you'll lose 20 if you do it, and then what you'll do is you'll get this worksheet from me with like a billion quadratic trig equations you're going to have to solve correctly, and then for each one that you do completely correctly, start to finish, I give you 3 points back for a max of 15 points.
What you should do is just make them write on the board like 100 times.
So,
I guess
anyway.
I know.
Alright.
Not set
Okay.
quadratic.
So there we go.
I can
All right,
same.
let's do the problem of the day real quick, and then we're going to move into the next lesson. The problem of the day is actually really similar to the one we just did. You know what? I'm moving the camera.
Score that's closer to me so we can pick up my voice better.
Good, that's important. Okay. Okay, quiet please. So here's what we have. What are we going to have to use in order to solve this? Double angle identity for cosine, right? Okay, so since we already have cosines, which cosine double angle identity should we use?
Cosine squared x, 2 cosine squared x minus 1.
Good, Rayon's got this. 2 cosine squared x minus 1. Okay, this is a quadratic. What should I do next?
Set it equal to 0.
Set it equal to 0. I'm going to move these over to this side, but I'm going to write them this way. So I have 2 cosine squared plus 3 cosine x. When I add 2, I get plus 1 equals 0. What do I do now?
Factor.
Factor. Everyone take a moment and factor. If you haven't already done so. You should have already done this since the problem of the day. By the way, if you're not good at factoring trig, it's just like factoring with x's, right? So if you just rewrote it 2x squared plus 3x plus 1 and factored that, it's the exact same factors, just the x's would become cosines, right? So it's the exact same process. 2 cosine and cosine, 1 and 1, plus and plus. So you end up with cosine x equals -1/2, or cosine x equals -1. What is our reference angle where cosine is 1/2?
Pi over 3.
Pi thirds, right? So we're going to have 2 pi thirds types of angles, and then cosine cosine is our which value, x or y?
X.
X value. Where is the x equal to -1?
Pi.
At pi. Good. All right, cosine is negative in which two quadrants?
2 and
Second and third, all students take calculus, right? So cosine's negative in the second and third quadrant, so we have 2 pi thirds and 4 pi thirds.
Word.
Okay? All right, moving on.